Hi friends, very good evening. Dr. Sanjit Singh here again to discuss MRP, which is an abbreviation standing for Materials Requirement Planning, and it is a part of operations management planning and control process. Now, let us try to understand what is material requirements planning. In simple words, material requirements planning is a planning of the materials required in terms of the quantity and the timing as per the requirement of master production schedule, or in short, MRP is a plan whereby we focus on materials acquisition required to produce a certain amount or quantity or number of products within a planned period. The materials required, the decision on the quantity and the timing of the materials required comes from master production schedule. Master production schedule is a planning on a chart showing the quantity or numbers of products to be produced at the specific time periods as per the plan schedule in the master production schedule. The MRP is based on these three points. For planning the MRP successfully, we need to adhere on these 3 points. The first point is we need to have a bill of material, which we get by breaking down the finished product into its assemblies and sub-assemblies. In short, the bill of material is a kind of list of the components and parts of a main product. Second important point to keep in mind while doing MRP planning is the MRP planning is carried out by scheduling backward, unlike MPS, which is planned forward. The third important point is that the MRP planning is actually the planning which is done by exploding the bill of materials and scheduling it backward. To understand the concept further, let us take an example of a chair. By looking into this picture, we will come to know we will come to know how a bill of material will look like when we take a chair as an example of a product. So if we list down all the parts and components and assemblies or sub-assemblies of a chair, then it will look something like this. A chair, a simple chair with the design as given in the picture can be disassembled or broken down into its components or individual components as seats, front legs, slide rails, back slats, and crossbars. So, bill of material of a chair can consist of these one, 2, 3, 4, 5 components is given in the diagram. Now, let us try to draw a product tree of the particular chair which we are talking about, and let us find out the time horizon or the time taken to assemble this chair. Let us try to break down the chair into its component and subcomponents. The first level of subassembly of chair will consist of these three subassemblies, which comprises of a leg assembly, a seat, and a back assembly. Now let us try to break down this level 1 subassembly into further sub-assemblies if possible. So first taking the leg assembly, we found it is possible to break down leg assembly into further smaller components of legs and crossbar. So a leg assembly consists of two legs and a crossbar to connect it together, to connect the two legs together into the leg assembly. Likewise, we try to break down the seats, but seat doesn't have any further subassembly. So let's move to the next sub-assembly, which is back assembly. And we were able to break down back assembly into further three components. That is the side rails, crossbar, and the back slats. So two side rails are required, one crossbar, and three back slats are required to assemble one back assembly. And beyond this level, we are not able to break down the product further into its further compositions of smaller parts. Now let us start from the bottom level, that is level 2, and try to find out the time taken to accomplish each of these parts and components and sub-assemblies given in the product structure tree of the chair. Here, let us begin from level 2, there's a bottom level. Producing legs will take 2 weeks, crossbar also 2 weeks, side rails, oh, back slides. So all these components will take 2 weeks to complete the task. Now after this, let us try to come to the level 1 and try to find out the time taken in the completion of the assembly of the components in level 1. Let's first take the example of leg assembly. So it takes 1 week to assemble the leg after we get two legs and one crossbar. Likewise, the production of seats will take 2 weeks and back assembly 1 week after receiving its three components, that is side rails, two side rails, one crossbar, and three black back slats. Now final assembling into the chair will take 1 week when three of these assemblies are available. One leg assembly, one seat, and one back assembly can be assembled into a chair in 1 week's time. This is how we can find out the time taken in reducing or acquiring each of the components as assemblies and sub-assemblies of a chair, and then we can estimate how much time it takes in total. Now, let us try to do a simple exercise in order to find the lead time in assembling the chair in the given example of ours. Since the final assembly of the chair takes 1 week, we should start assembling the chair at the beginning of week 4 so that the chair will get assembled at the end of week 4, and on the beginning of week 5 we can deliver the chair to the customer. And this following diagram shows how we have calculated the lead time by going backward from week number 5 to week number 4 to 3, then 2. Since it takes 1 week to assemble the final chair, then the three components or the three sub-assemblies, the back assembly, the seat, and the leg assembly should be available on week number 4. Since it takes 1 week to assemble the leg and the back, which should start assembling the back and the leg assembly on week number 3. And for the seats on week number 2, we have to start. Since it takes 2 weeks, it will get completed on week number 4. Now coming further backward, the back assembly comprises of three components. One back assembly will require three back slats two side rails, and one crossbar, which takes 2 weeks to be manufactured or produced. So from week 3, it will go backward to week 1. Same the case with leg assembly. Since we want to begin the work for assembling the leg in week number 3, we have to plan for its subcomponents, that is legs and crossbar, 2 weeks prior. That is the beginning of week number 1. Now we have seen how we have exploded the bill of material of chair and also estimated the lead time by planning backward. So now in order to do the actual planning of the material requirement, we need three information. The first one is of course the bill of materials, which are the parts and components for assembling a product. We also need to look into our inventory record to check out whether any inventory of the parts and components and sub-assemblies of the chair is available in the store. If adequate quantity is available in store, we can drop the task of ordering the parts and sub-assemblies to the supplier. Or if we manufacture in-house, then we can deduct all those quantities which are available in the inventory record. The third is we have to look into the master schedule too. And why it is required is because the master schedule gives us the idea of when, that is in what period and in what quantity the materials has to be, or the finished product has to be supplied or delivered to the customer. The date and the time of the final delivery of the finished products to be made available to the customer is reflected in the master schedule, and this gives the point from where actually we need to plan the MRP schedule backward. An MRP an MRP usually should be able to provide the following information of gross requirements, scheduled receipts, projected ending inventory, net requirements, planned receipts, and planned orders. Now, in order to understand better, let us move back to our example of a chair. In this figure, we can see MPS schedule of delivering the chairs on week 5, 6, and 7. We have taken the first or the beginning output date on week number 5 because the total lead time taken to manufacture a chair is 5 weeks. So we would be able to deliver the chair to the customer on week number 5, in the beginning of week number 5. So let us start planning our MRP from week number 5. The MPS schedule due date on week number 5 is 500 units. So if you want to deliver 500 units of chair to the customer on week number 5, we need to have its assemblies 1 week prior because it takes 1 week to assemble the final chair. If we have three of its sub assemblies, which are uh, one seat, one leg assembly, and one back assembly. Let's take its the first assembly sub assembly of chair which is required, the seat. So we need to have seat on week number 4 is given by the alphabet D in red color or in red circle. Since we have seen in the product structure that producing a seed will takes 2 weeks. So if the gross requirement is 500 seeds on week number 4, we need to plan the ordering of the seeds 2 weeks prior. So the order has to be planned on week number 2. But then should we plan all the five quantities? Oh, sorry, 500 quantities should be ordered on week number 2. It depends upon the next consideration, which is the net requirement. So the gross requirement is 500, but we have to find out whether we have any in-hand inventory, ending inventory. Sorry, any projected inventory on the previous week, that is week number 3. So since there is no uh, inventory in the previous week, no ending inventory in the previous week, so the gross requirement becomes the net requirement of 500 units. So we want to receive 500 units as a plan received on week number 4. So that's why we'll have to plan it 2 weeks before. That's why this in the plan receipt we have 500 units. Since these 500 units is planned, the order is planned on week number 2nd, it's shown by G, and this will likewise for week number 5. We have uh, net requirement of gross requirement of 400 units. So we'll have to check out whether we have previous inventory on week number 4. Projected inventory week number 4 is 0. So the net requirement becomes 400. 400 minus 0 is 400. And so the plan receipt also will be 400. And the plan order also will be 400. Now, coming to this slide, we will try to understand the next assembly, the second assembly, that is leg assembly, and the third sub-assembly, that is back assembly, for planning the metal requirement. Here again, same case as that of seats, the leg assembly and the back assembly, both the requirement will be 500 unit each on week number 4, since we have to assemble it on, uh, to finish assembling it on the beginning of week number 5. So let's get into leg assemblies table. So on the week 4 we require 500 units. Okay, and the now the gross requirement is 500 unit, but we have in-hand inventory on week number 3, which is 25, and this 25 is carried forward, and we uh, added up with the gross requirement 500. So the total, so we already have a inventory of 25 leg assemblies on week number 3. So we'll deduct this 25 from 500 gross requirements, and we get net requirement, which is 475, and it's written over here in net requirement 475 is required. So that's why ideally we should be uh, giving an order of 475. That is, the planned order should be of 475 units, and which should be placed on week number 3. Why on week number 3? Since the uh, production of leg assembly will take only 1 week. So that's why we have to place the order 1 week prior. But what we are seeing here, we are seeing the planned order is 1,000, and that's why the planned receipt also is 1,000. Then why 1,000? Why not 475 units? Here, one thing we need to understand, is the requirement of the vendor or the supplier too. Since the supplier is willing to the supply minimum 1000 units per order in a single order, we cannot order less than 1000 units. That we cannot order for 75 units to the supplier. So let's just assume that there is only one supplier available in the market. So that's why we need to give an order of 1000 units minimum. So that's why the planned receipt and planned order becomes 1000 instead of 475. So as the planned order is 1000, the receipt also will be 1000 on week number 4. Now we are getting much more inventory than which is required. So let us calculate the ending inventory. So 1000 minus 475 is 525. So this 525 is where it comes from by deducting the net requirements from the planned receipt. So let us look into the last table in this slide, which is the table of back assembly. So in the week 4, we require 500 pack assembly, like leg assembly and seat assembly. So let us check out the gross requirement and the net requirement first. The gross requirement is 500 itself. And what will be the net requirement? So in order to calculate the net requirement, first we need to know the inventory which is lying with us, the in-hand inventory on week number 3, which is 250 units. So 250 units already there. So we minus 250 from 500, then the net requirement will be 250 units only. So we we have to place 250 units 1 week ahead, 1 week prior. That is on week number 3. Okay. So the plan order is here. It is 250. It's exactly what is required. And how is it possible? Because here again, the condition of the supplier is minimum 250 order, which we fulfill. And the requirement, the exact requirement, uh, is also the minimum order requirement of the supplier. So we place 250 orders 1 week prior, and it's getting delivered on week number 4. So this is how it comes. And the inventory in hand will be 0 because the plan received minus the net requirement, it is 0. Likewise, for uh fifth week, the requirement is 400 back assembly, and the same follows the net requirement. Since the inventory is 0, the net requirement also will become, since the previous in-hand inventory of the previous week is 0, then the net requirement will become 400, and the planned receipt will be 400, and we'll be placing 400 units in week number 4 because it's possible to place 400 exactly because the minimum order is 250. Now, planning backward from the leg assembly to the legs, back assembly to its component parts. So let us take only one example for today's discussion. Let us take the example of leg assembly. So in the previous slide, we have seen that we have to order 1000 units because the minimum order was 1000 units. So if you are ordering the leg assembly on week number 3 uh, of 1000 units, then how much legs has to be ordered, on how much legs should be available, how many legs will be required to assemble 1000 units of leg assembly. Since a leg assembly consists of 2 legs, so we'll require 2000 units. So the gross requirement will be 2000 units as a gross requirement for legs. And now, how will we plan the MRP schedule of legs is because the legs takes 2 weeks to get manufactured or produced, we require to order it 2 weeks prior. So the gross requirement is 2000. And in order to find out the net requirement, we have to look into the previous in an inventory where we find that we have 25 legs on the previous week's inventory. So we deduct it from the gross requirement. So the net requirement will be 1975. So we place an order of this quantity on week number 1, right? And this is third week. So we need to place 2 weeks prior. On for then week number 1 we place it. Then the planned visit will be after 2 weeks, that is on third week, and it's shown over here.